All right, so here it says simplify each difference. Oof, I guess they're all subtracting. Hopefully I meant to do that. I think some of these might be adding that you'll need to be able to do too. Shoot, I didn't make, I should have made your packet like 120 problems instead. But if you can subtract, you can add. Because what we're going to do is when we see subtracting that we're taking this clump minus this clump over here, we're going to really turn this into an addition problem. But before we can do that, we need to put a multiplier of 1 right here. But notice that 1 is negative because there's a minus sign in front of it. You can do the old chop slash if you'd like to emphasize that that 1 is negative. Let's distribute that through. We're doing this to turn this into an addition problem instead of a subtraction problem the way all these look. Look, we're always subtracting the first clump minus the second clump. So we copy down the first parentheses. Could have rewritten it in standard form. That would have been good. But now let's distribute that negative 1 to each of the terms in the second parentheses. So we get negative 4p, negative 8, and positive p squared. We're multiplying by a negative, makes the signs the opposite. It's essentially what we just did there by subtracting. It's made all the terms opposite of what they were, and now we combine like terms. And so start with your largest term first. This is p to the third, so that's my largest degree. So it's 4p to the third. I can't combine that with anything. But now that I've used it, I'm going to cross it off. Helps me keep track of what's going on. Let's go to the p squareds next. I'm going to put a 1 in front of this p squared at the end. Right here, it's a positive 1p squared. And we have 5p squared. That gives you 6p squared. When you combine like terms, they have to have the same variable and power. And you add the coefficients in front. And when you do that, you do not change the variable or the power. There we have some p's, 5p and negative 4p. That makes 1p, or just a positive p. Let's cross those out. And last but not least, we've got negative 3 plus negative 8, which is negative 11. There we are. So the key there is to multiply. When you see a minus sign in front of a whole grouping or polynomial, to multiply by negative 1. And then combine like terms or add the polynomials together. All right, let's try, I'm gonna try 61 where I have a little more space. Again, everything's getting multiplied by 1, except for this one's getting multiplied by a negative 1.
Try a piece of lettuce, but he just looked at it and he didn't like it.
He likes steak, not lettuce.
Okay.
We're not going to feed him that, though. Alrighty, so now let's distribute that negative 1 through. And I guess maybe I should say, well, again, why I'm doing that is to bring down a plus sign. Now I'm adding to that left polynomial. Well, distribute the negative 1 through now. So negative 8x positive, because negative 1 times negative 5x squared is positive 5x squared. And negative 1 times negative 3 is positive 3. Leave it, dog. Come on, Bo. Leave it. So then, let's start with the highest power, x to the third. Then move on to x squared. So we get 13x squared. Cross those off. Then 2x plus negative 8x is negative 6x. And then check it out. Oh, just kidding. We have a 7 and a 3. Good thing I'm crossing things off. I actually did not see this 7 initially. Probably because I'm staring at a dog and a 6-year-old girl pulling the dog away. So there we are. And I've combined everything that I could combine, and I've written my answer in standard form. So that looks pretty darn good. Way to go, Mr. P
To get him over
and
there,
math students.
to get him over